So I have shown you how to do all the techniques and given you all the tools to modify logs and exponents in order to solve any type of equation that involves a log or exponent. So let's use all of our tools, all of our properties we've seen up to this point to help us solve. First question, log 2 plus log x equals 1. The issue here is that I have 2 logs, and I want to turn those 2 into just 1. That's going to make solving a lot easier. So what do I have to do to turn those 2 into 1?
Multiply them.
Multiply them, or use my product rule, right? Notice that they have the same base, log of base 10, and since these are same base and they're being added, I can multiply these values inside. That gives me 2x equals 1. Now this looks like a lot cleaner problem to solve. We have solved questions like this before already. Does anybody remember what you would do here?
Multiply that, non-trivial. You know,
To even simplify this even more and make it even a more easier equation? You would take the log and turn it into a, well, what's the opposite of a log?
In. No.
The inverse of a log function is an
out.
All right, I'll help you out. I'll throw you one this time. What you want to do is to convert this into an exponent. Remember doing that? Maybe?
Oh.
So what's the base of my exponent? I have 10, 2x, and 1. My base would be
10.
the same base as the log 10. What's the power?
1.
The power is always going to be what your log equals, so this number over here on the other side. So 10 to the first power equals 2x. Now look how that's a lot easier equation to solve for x. So what would you do next?
Divide 2.
Very good. Divide by 2 on both sides, and you end up with x equals 5. Now remember, with logs, we need to make sure we check our work. Does log 2 plus log 5 equal 1? Kind of a weird thing to see. So let's make sure we check log 2 plus log 5. What do you know? It does equal 1. So I verified that x does in fact equal 5. So notice I've used 2 things we've learned so far: how to convert and how to use our log properties. So for the next question, follow the same path, the same steps. What would you do first?
Make it into 1.
Very good. Make it into 1, which looks like log of what?
8x.
Very good. 8 times x. 8x equals 2. Now what would be my next step?
Convert it.
Now convert. So what does this look like as an exponent?
10.
10.
And with the next one is 2.
Very good.
Equals 8x.
Equals 8x. So yes, convert.
10 times 10.
So that's 10 times 10, that's 100
Divided by 8.
over 8x.
Divided by 8.
Divide by 8 on both sides. And roughly simplifies this to 25 halves over x. Plug in just to make sure that log 25 halves plus log 8 equals 2. Let's see, log of 25 halves plus log 8. What do you know? It does in fact equal 2. So I've checked my work. I confirm that I am correct. Now, those were steps that turn into a linear function. Let's see what happens when it turns into a quadratic. So again, what's my first step?
Equal 1.
I have too many logs here to work with, so let me combine it into 1. That's going to give me log 8 of what?
2. Oh, no. 2, 4x squared.
2 times 4 is
8.
8.
8x.
X squared equals 1. Now, very difficult to solve it like this in this format, so you would turn it into a
0.
exponent. So as an exponent, it looks like 8 to the power of 1 equals
8.
8x squared. Now pause for a minute. I have a quadratic. How do we solve quadratics? I could factor, but let's just stick with the usual routine, which is set equal to 0. So let me move this 8 over. That's going to give me 0 equals 8x squared minus 8. There's my quadratic, set equal to 0. And now you would want to graph it. So let's go ahead and look at the graph. Identify our x-intercepts, which are -1 and +1. So finally, that's what x equals. As I mentioned, if you end up with a negative value for your x, be very cautious. Logs don't like negative values. So let's plug it in just to make sure it doesn't come into being a negative. Plug it in here, I get negative squared, which turns it into a positive. Times 4 stays positive, so we're okay. There's not any kind of no solution there. But you want to test them both either way to see if it works, and trust me, it does. We checked it last period. So you may not always run into a linear equation, you may run into a quadratic. Please remember your steps in solving a quadratic equation. Now we saw converting a log into an exponent one way. We also saw another way. So for right now, let's discount this additional log here. We saw that when you have two logs on opposite side of an equal sign and they have the same base, then what you could do is cancel them out and just look at the values. And I get x equals 2.
Crazy.
Well, we saw that same thing with exponents, right? If they had the same base, cross those out and just look at the powers. X equals 2. Now, this only works when you have one exponent on one side and one on the other side. One log on one side, one log on the other side. I have 2 on this side and 1 on this side. I can't use this technique and start canceling out all the same logs. Doesn't work that way. So what do you think I have to do first? Combine, yeah. So this one that has 2, more than one I need, let's turn it into just one log. So log base 9 of x plus 6, and I have a minus.
Plus 6 divided by.
Very good. So I'm going to use my quotient rule. This is a positive log, so this x plus 6 value is in the numerator. This is a negative log, so that x goes in the denominator. And then I have this, which I'm not going to touch. It's fine. Just one log.
Good job.
Now we can use that property. 2 logs on different sides of the equal sign, they have the same base, so I can go ahead and throw those out and just focus on the values. I get log x plus 6 over x equals 2. How would you solve that? I can rewrite it. X plus 6 divided by x equals 2. I'm guaranteed there's something about this that's bothering you, which is what?
It's a fraction.
It's a fraction. I have this x in the denominator. How would you get rid of this x? What's that? Multiply. Yeah. Multiplying an x here will make that cancel, won't it? So let me multiply on the other side. That's going to give me x plus 6 equals 2x, which now is a lot easier to solve. So now you should obviously see what the next thing you want to do is subtract x on both sides here, and you get
6 equals x.
6 equals x, or x equals 6. Again, we are dealing with logs, so you'll want to plug these in just to make sure they work. If this was a negative 6, you would be in trouble. Plugging it in here gives you a negative value inside of a log. It would break. Luckily, we're positive. And checking it out does work. We checked it first period. So x does in fact equal 6. So don't forget about the property. 2 logs that are the same base, you can cancel them out as long as it's just 1 and 1. If there's not, make it 1 and 1. So let me give you a moment to see if you can answer this next one here. log base 5 of 6 plus log base 5 of 2x squared equals log base 5 of 48. Solve for x. Alright, first thing I want to do is to do what? First step.
Yeah, you need to combine it to one log.
Yep. Combine, in this case, since we're adding, I need to multiply. So I get log, whoa. Log with the base 5. And what happens when you multiply 6 and 2x squared? You get
12x squared.
12x squared equals log base 5 of 48. Now what?
You can cross out log 5.
Very good. They have the same base. Let's no longer look at those logs. I'm left with 12x squared equals 48. What would you do now?
Equal to 0.
Very good. Let's set it equal to 0. That's one way you could do it. There's other ways. Now I have quadratic that's equal to 0. Let's go ahead and graph it. So looking at the graph, my values are
2 and negative 2.
very good. 2 and negative 2. So x equals 2 and negative 2.
That makes so much sense.
Plug those into your log just to make sure they work, and trust me, they do. I see a negative log, but that's okay because it gets squared and turns into a positive log.
Who the fuck is this?
These next questions, I want to make sure that you have good strategies in order to solve. So looking at this one, what would be the best strategy to do first?
Sorry.
What would be a good first strategy?
Log by itself.
Okay, so
You gotta eliminate that negative 2
How?
in front of the log. You had to.
how? How would you get rid of that negative 2 being multiplied to the log?
How would you get it? Down. Or you just.
What's the opposite of multiplying to a log?
Dividing.
Dividing.
Oh my god.
So note, this is a property, right? We could put this here, could we not? We could move it that way. But that would probably overcomplicate the problem than it should be. Because, like you mentioned first, it might be a lot smarter to just divide by this negative 2
It was right there.
and get rid of it that way.
For fuck's sake.
That gives me log base 5 of 7x equals negative 1. Now what would you do?
Converted.
Very good. Hopefully, by the end of this week, it should become second nature. Once you see this and you know you have to solve, what you want to do next is to convert it. So it's 5 with the power of negative 1 to 7x. This becomes 1/5 equals 7x. And then last but not least, divide by 7. That gives me a value of x equals 1/35.
What the?
Yeah, because this is, you're essentially multiplying by 1/7. So you do some multiplication. 5 times 7 is 1/35. If you don't believe me, use a calculator. Next, what would be a good first step here? Move the 10 to the other side. So the opposite of a minus 10 is a plus 10. That's going to give me log base 3 of n plus 3 equals 0. Now what? Convert. Again, hopefully this is going to be second nature. So that's 3 to the power of 0 equals n plus 3. What is 3 to the power of 0? It is, in fact, 1 equals n plus 3. And then now, one more thing to do. Subtract 3. N equals negative 2. Uh-oh, a negative value. Let's check it. If I plug it in here, I better not get a negative log. Negative 2 plus 3, I end up with a positive 1, so it won't crash that log. We just need to test to make sure I get negative 10 on this side. And you do, because 3 to any power of 1 here, if you follow that one property, gives me 0. Negative 10 plus 0 is negative 10. Or you can just plug in the calculator. Math. One more. I want to refresh over properties of exponents or how to solve exponents. What was our main goal when we want to solve an exponent?
Get the same basis?
Very good. They need to be the same base. That way, just like the logs, I can just cancel out the bases. What do you think would be a good base to use here? I have 16, 4, and 2. What's the smallest number that can be raised to a power and get all three of those numbers? 2. So this 2 is going to stay the same. I am going to change 4 because 4 is 2 to what power? 2. And I need to multiply that to anything that's already there, if you can recall. So I need to multiply 2 to negative 2p. And then 16 is 2 to what power?
Or no?
2 times 2 is 4. Times 2 is 8.
4.
Times 2 is 16. So 4. And again,
So long just to figure that out.
I need to multiply 4 to anything that's already there. Please don't make the mistake and only multiply it to that 2p. When you have that raised up, it needs to be multiplied to everything that was already there. So that's why I'm putting it in parentheses. Just like with logs, can I go ahead and discount all the bases and circle all of these together when I have 2 on this side and 1 on this side?
Yeah.
What do we do with logs? What was our goal with logs? I had 2 on this side, 1 on this side. You wanted to do what?
Oh my
Get 1.
God.
Yeah.
So I need to get 1 exponent on this side so that I can use that one particular property. Well, first let me go ahead and simplify my exponents here. Or go ahead and distribute. So that's going to give me 2. 4 times 2p is 8p. And 4 times negative 3 is negative 12. Times 2 to the power of negative 4p equals 2 to the power of 4. I did that because let's use our law of exponents. What happens when you have 2 exponents of the same base? You do what with the powers? Add them. So I'm going to look at these values here and add them together. That's going to give me 2 to the power of 8p minus 4p is 4p minus 12 equals 2 to the power of 4. Now I can go ahead and get rid of the base. So since these are equal, let's ignore them and focus on our exponents. 4p minus 12 equals 4. Luckily it's linear. Should be pretty easy to solve from here. So I'm going to add 12 to both sides. That gives me 4p equals 16. And then last but not least, divide by 4, p equals what? P equals 4. Now you don't have to worry about any kind of extraneous solutions with exponents, so we know it's not going to crash on us. But it would be a good idea to plug it in anyway, just to make sure you know you're right.